Hi everyone, and welcome to this podcast dedicated to the multiplier effect. In the Keynesian analysis, the equilibrium does not correspond to a full employment situation, but to what we call an underemployment equilibrium, because part of the production is not sold due to insufficient demand, and because there is unemployment remaining in the economy at equilibrium. In this situation, policymakers may want to increase activity through a stimulus policy. The impact of such a policy on production can be measured using the multiplier. The multiplier therefore answers the following question: what is the impact of a fiscal policy on the GDP? Kahn and Keynes are the two first economists who attempted to answer this question. Keynes starts from the IS equation. If we look at it more closely, we can identify the autonomous components of the demand in this equation. C0, the incompressible consumption. I0, the autonomous investment. T, taxes, which we will assume are flat here, meaning that they do not depend on the income. And G, public spending. Keynes showed that thanks to the multiplier effect, an initial increase in one of these autonomous components would trigger an even larger increase in production, larger than the initial increase. However, this multiplier effect relies on four strong assumptions. One, the reasoning works only in the short term. The production capacities are fixed, and part of them are not utilized. As we said earlier, the short-term equilibrium is an underemployment equilibrium, in which the production is constrained by the effective demand. Second, prices and wages are fixed, again, because we are in the short term. Taxes are flat, not proportional to income. In other words, they are exogenous and equal to a constant T. And finally, we ignore the financial and monetary sphere here. We only focus on the real sphere, on the goods market. So when we talk about the simple multiplier, we will assume that the interest rate is constant. One last point, in the next slides, we are going to describe the multiplier effect in the specific case that G increases, that the public spending increases. Remember that the exact same reasoning applies if instead of G, we have an increase in C0 or an increase in I0, for example. The concept of the Keynesian multiplier is actually quite simple. The idea is that when the government increases public spending, for instance, this will provide a new source of income for different economic agents. These will generate new expenses, which will generate new income, and so on and so forth. So, from an initial spending from the government, the economy benefits from successive waves of new income. So now let's dive in more details into the multiplier. On the graph here, you can see the production on the x-axis and the demand on the y-axis. The blue line represents the equality between production and demand. For example, this equality is verified at E0. From this point, the state increases public spending by an amount delta G. So what happens then? Well, first, demand increases and we get to point A. At point A, demand is higher than production, so the supply will increase to adjust to the new demand. And so the revenue increases by an amount delta Y1 equals delta G. This increase in income will trigger an increase in consumption by an amount C1 times delta Y1, which is equal to C1 times delta G. Just a reminder, here C1 is the marginal propensity to consume in the case of an affine consumption function, as we have in the Keynesian consumption function. This increase in consumption leads to a new increase in demand towards point C. This increase in demand will then lead to a new increase in production and therefore in income. Hence, we end up with an increase in income delta Y2 equals to C1 times delta G. Note that because C1 is between 0 and 1, this second wave of increase in income is lower than the first one, delta Y1. These different waves will continue until we reach the final equilibrium E1, where we have equality between demand and production. If we want to calculate the overall increase in income over the whole process, we can add all the additional increases in income that occurred at each wave. This gives us delta G plus delta G times C1 plus delta G times C1 squared, and so on and so on. Because C1 is between 0 and 1, the sum converges towards 1 over 1 minus C1 times delta G. This coefficient, 1 over 1 minus C1, is what we call the Keynesian multiplier. Note that the coefficient is higher than 1. Overall, the public spending delta G triggered a succession of revenue increases, which in the end will be higher than the initial spending of the state. This means that the government, through public spending, triggers an iterative process of revenue creation through consumption. The higher the marginal propensity to consume, the larger the size of the multiplier. This provides the theoretical foundation justifying government intervention, because according to this, in an underemployment situation, an increase in public spending has a positive impact on the activity. We've now covered the simple multiplier. There are some variants to this multiplier, depending on the type of autonomous component that varies. For example, say that instead of increasing public spending, the government decides to decrease taxes to stimulate the activity. In this case, we will calculate what we call a tax multiplier. This tax multiplier is not the same as the budget multiplier, because a decrease in taxes does not trigger directly an increase in demand. When taxes decrease, first, the disposable income of households will increase, which will then trigger an increase in consumption by an amount C1 times delta T. In other words, the first step of the multiplier is different. Instead of having a number 1 here as the first term in our equation, we have directly C1. The first variation of the demand is lower in the case of a decrease in taxes than it is in the case of an increase in public spending. Because the impact here is indirect, as it goes through the disposable income, which is partly consumed and partly saved. The tax multiplier is then minus C1 over 1 minus C1, and so it is lower than the budget multiplier in absolute terms. Note the minus sign, because here we have a decrease in taxes, which leads to an increase in demand. The relationships are opposite. There's another type of multiplier, which is the balanced budget multiplier. This is when the government finances the increase in public spending by an increase in taxes, keeping constant the budget. In this case, we have a combination of two multipliers, the budget multiplier on one hand and the tax multiplier on the other hand. Overall, the total multiplier is equal to 1. This means that production and income increase, in this case in the same proportion as public spending, without creating new deficits. This impact is called the Havel-Moh theorem, which states that if there is simultaneously an increase in public spending and an equivalent increase in taxes, the budget deficit will not vary, and yet there will still be a positive impact on the economic activity, which will be equal to the initial increase in public spending. Be careful. Remember that what we just learned about the multiplier relies on very specific assumptions. For instance, we assumed that the interest rate was constant. We will now remove this assumption to integrate the financial and monetary sphere into the analysis. In the plane YR, we start at the point E0. Suppose the government increases public spending. IS shifts to the right. And the new equilibrium E1 corresponds to an increase in income Y1 and also to an increase in the interest rate. We can clearly see here that the observed increase is lower than the increase we would have observed in the simple version of the multiplier. Indeed, in the simple version, the interest rate was constant. On our graph, we could have reached point F with a constant interest rate. But if we consider the financial and monetary sphere, we need to take into account the mode of financing that the government will use. For instance, the government will borrow money to increase its public spending by issuing new bonds on the bonds market. In other words, the government increases the demand for loanable funds. Therefore, there is an excess demand on the loanable funds market, which triggers an increase in the interest rate. This then results in a decrease in investment, which is going to reduce the initial impact of the increase in public spending. This is what we call the financial crowding out effect. Simply put, this effect means that if an increase in public spending is financed through borrowing, it will increase the interest rate and prevent private companies from accessing loanable funds. The public spending replaces or crowds out private spending. The multiplier is therefore lower than at constant interest rate. Graphically, the crowding out effect is the difference between YF and Y1. Let's now calculate the multiplier in the ISLM model, which includes the monetary and financial sphere. Remember that a multiplier measures the effect of the variation of one exogenous variable on an endogenous variable. In our example, this corresponds to measuring the impact of an increase in public spending dg on the revenue y. To do this, we start from the equations IS and LM, and we differentiate them with respect to dy, dr, and dg. After that, we play around a little bit with LM to isolate dr, and then we replace dr in the IS equation. After doing some simple math, we obtain the multiplier dy in the case of an increase in public spending. We see here that dy is lower than the simple multiplier we had calculated before. Before, it was 1 over 1 minus c prime. Now, there's an additional term in the denominator. This term describes the impact of the increase in public spending on the interest rate. And it describes the impact of this variation of the interest rate on investment. In other words, this term illustrates the financial crowding out effect. The financial crowding out effect is the impact of the increase in the interest rate on the investment and so on the income. Graphically, it's the difference between YF and Y1. This effect can be quantified. We can calculate it by doing the difference between the simple multiplier, which is the multiplier when we assume the interest rate is constant, and the multiplier with R endogenous, not constant. Before concluding this video, 3 remarks. 1, the crowding out effect is related to the way the government chooses to finance its public spending. If the state decides to finance it through money creation, then we could reach point F. In this case, the supply of money would compensate the effects of an increase in demand of loanable funds. We call this a policy mix, which we will talk about a lot more in the next lesson. Second remark, it is clear, looking at the graphs, that the crowding out effect will depend on the slopes of IS and LM. The next podcast is dedicated to this. Final point. Remember that so far, we've only been reasoning in the short term, at constant prices and wages. When, later on, we remove this assumption, our conclusions on the efficiency of fiscal policies will be different.